In this example, we're going to look at cross sections. So not necessarily symmetry, but just cutting things in sections. So cross sections of a right circular cone are called conic sections or conics. The intersection of the cone and the plane parallel to the base of the cone. When the plane parallel to the base of the cone intersects the cone, the cross section is a circle. And so if you took a cone and you just sliced out part of it and you looked at it, held it up and looked at it, it would be a circle. This will always be the case unless the plane intersects the vertex. Right? So you can see in this little animation here, the circle is getting bigger, but it's still a circle. When the plane perpendicular to the base of the cone intersects the cone, it does so along its curved lateral surface and through its base. This shape is a curved surface and one flat edge. The curve formed has a special name called a hyperbola, not a hyperbola, hyperbola. Any cross section formed in this manner, excluding the intersection of a plane and the vertex, will have a flat edge and one hyperbolic curve. The cross section formed by the intersection of the perpendicular plane and the vertex of the cone is a triangle. So we can see as this animation moves along, we've got that nice curve shape, and it's getting steeper and steeper and steeper until right there, oh, I almost stopped it in time. It's a perfect triangle where it gets all pointy, and then it gets rounded again. The intersection of the cone and the plane with the same slope as the slant height of the cone. So this blue plane is now at the same angle as the side of the cone. When the plane has the same slope as the slant height of the cone, the intersection is along its curved lateral surface and through its base. This shape has a curved surface and one flat edge, just like previously. The curve formed has a special name called a parabola. As the plane moves through the cone at this angle, each cross section has one flat edge and one parabolic curve. So we have a parabola this time. And notice that the parabola gets fatter until it reaches the very end. And then when you come back, it starts out really wide and it gets skinnier. And the intersection of the cone and a plane with a slope different than the slant height. So this is got a steeper or a flatter slope. When the plane has a slope that is different than the slant height of the cone, it can intersect the cone at an oval or ellipsis. So notice it's not a perfect circle. You kind of get some weird shapes going on in there. And in the example, we focused on two-dimensional cross sections. However, the cross section formed by an intersection of a plane and the vertice of the cone is a point, right, when it gets right up there to the tippy top. And the cross section formed by the intersection of the plane and the edge of the cone is a line right before it actually enters the cone. Notice that it's just a perfect line.